Alright, so hello and welcome. Here we are. We're going to take a look at another problem. Haven't looked at it yet. I'm nervous. Let's see how this goes. Try to do it under an hour. Yeah, I have some other thoughts I'd like to share, but I'm just gonna keep those to myself for now. Let's get it going. So, reverse nodes in K group. Let's take a look. See how we do. See how we do. Yeah, I was looking. There's a few different things I've been thinking about recently. But we don't have to talk about those things now. So related to programming problems. Given a linked list, reverse the nodes of a linked list k at a time, return its modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as is. You may not alter the values in the list nodes, only nodes themselves may be changed. Okay, so there's a really nifty way of doing this. Basically, you're reversing sections of the linked list. There's like a very clever way, I remember way back when, of reversing just one section of a linked list. Let me think if I can, let's see if we can remember how to do that using double pointers. One of the few times I've used double pointers to do this. So here, if k is 2, you're going to swap 1 and 2 and then 3 and 4 and leave 5. And here, if k is 3, you're going to swap 1, 2, 3 and leave 4, 5. And that's fairly simple. Okay, number of nodes in the list in the range is SC. SC is between 1 and 5,000. Node values between 0 and 1,000, and k is between 1 and SC. Can you solve the problem in constant extra memory space? Yes. So it's kind of a tricky thing, but basically the idea, yeah, I've kind of seen a similar problem. So what we're going to do is actually first need to figure out how many sections that you need to do, and then stop there, right? So you have a sort of a for loop of only those sections. And we'll get to that in a moment. We want to write a general routine that just takes one portion of a linked list, sort of a starting point and a certain number of nodes out, and we'll reverse all those nodes. We'll write that routine, and then we're going to apply that routine a certain number of times. I think we just need one routine to get the total length of the list. And yeah, get the total length of the list and then just perform that. So that's one pass through to get the total length of the list, divide that by whatever our number is to give us how many times we're going to perform this. And yeah, and return the head of the list, I believe, once it's done. Yeah, I think that subroutine, we could just run that subroutine this however many times you need to do it, and that subroutine is the sort of the interesting part. So let's write each of those. So we'll say we'll have the auto length or define length, something like this, and we'll call that, have a subroutine. I call that a lambda rather. List node pointer, this could be const. We're not going to modify anything. Call it R. And we're going to say int count equals 0 for R. R is equal to R. Next. And we just increment the count. And you can actually put that in. So we start off at 0 while R, and I guess we increment the count. Yeah, and something like this. I think that works. The one issue here, so if there's nothing, if R is empty, it returns 0. If there's 1, we count it. If there's 2, we would move once to the second node, it would be 1. Second, another time to the ending node, we have 2. Yeah, I think that's correct. So find length. So int total length is going to be find length of the head. And we're going to say this isn't going to change. We're going to say do we want now? I guess with integers you really don't need this to be a reference. This could just be constant. We want to know. Let's just call this like iterations. It's going to be total length. Oops. Divided by k, and we're not going to check for like we're gonna assume these constraints are correct. We're not going to have extra code to check for like bad inputs. And now we have so we're going to say reverse section list section, or just reverse section list section. And so say like this. Reverse list section. So we're going to have an initial node, and actually the thing that's tricky here is there could be a previous node that you need access to, right? Then you have the head, and or just R, we'll say, and then we int amount, or yeah, we could say number, or how would you express it? I want to just say x. I like to reserve x for loops and things like indices, but x kind of works here. I want to say nodes, just nodes, num nodes, or yeah, num nodes or n nodes, or n. Actually, n's fine. N is good. Actually, n's a good one. Okay, so yeah, so this is if there is a previous node at all, and what we're going to do is say something like this. So you can use, the way it works is like this. So if you have a linked list, how are we doing on time here? I just don't remember exactly how to do this. It's been a while. It's been years, actually. It's literally been years. Okay. So you have these nodes. This is not something I came up with myself, by the way. It's something I've seen. Someone else showed it to me online. All right. So you got, okay. Oh wow. All right. So what we're going to do is, let's say we want to reverse this section, right? What we can do is you can actually take, you can move this node over, swap it one at a time. It's a little confusing how it works, but you could swap these two first, and it would look like the following. It's actually not. It's not swapping those two. It's more like, yeah, you do. So let's say this is like x and y and z, something like that. You swap, so you'd end up with y, x. But it's actually you swap. Hello, hey, how's it going, Melito? Welcome back. Hello. Welcome. You caught me at a time where I'm actually, I don't remember exactly how this works, so I have to ponder it, think about it for a second. And what happens is you swap the first element with what's to the right, with the I guess this element, I suppose. And then what happens is you shift over to point to that next element, right? So you have sort of pointer to the first element, pointer to the second element. And then what you do is you actually swap the next thing. So you shift this over yet one more. So these get swapped. You go to Z, right? And you end up here now. So you had a pointer, you had a pointer here, had a pointer here. You swap those two. And now your pointer, you stick your first pointer back to the beginning, but you update this next pointer over here. right? And now you swap these two, right? And you'll see, is it these two that swap? I forget exactly how this works. And then you end up with Z in the front. No. So you don't just swap. Yeah, that's how it works. Okay. You don't swap them. What you do is you move Z over here. This is actually really what you're doing is you move Z to the front. And then now, this points to, so you move Z to the front. Yeah, I think that's how it works. You take the next element, you put it in the front. So you reverse it that way. So you go X, Y, Z becomes Y, X, Z becomes Z, Y, X. That's how you do it. Yeah, now I understand. Yeah, now I remember how this works. So that's one way of reversing your linked list, is that you actually take each element. So your first, blue pointer points to Y, then it points to Z, and your orange pointer always points to the first one. So it points to X, then it points to Y, then it points to Z again. And that's how you can do sort of n nodes reversed. Tricky thing here is so this blue pointer points to Y, we swap Y with X, now it points to X, then it goes to the next, goes to Z, then we would swap. So actually what you want to do is you want to actually update the blue pointer to a temporary pointer. So you want to set like a temporary pointer here to Z, right? And then set a temporary pointer to Z, and then swap X and Y, and then update this pointer to this one. So this pointer then points to this pointer. Yeah. So that's actually where you end up with the double pointers, by the way. The double pointers are you don't actually necessarily need double pointers here, I think. Yeah, this this pointer then points to what this pointer is pointing at. Yeah, and then you have a pointer pointing to X, pointer pointing to Z. I think I remember doing this with double pointers though, way back when. I don't think you need double pointers. I think it's okay to use 2 pointers, or yeah, to use, I guess it'd be 3 pointers, right? So then you swap X with Z. No, excuse me. Then you swap. Yeah. No. It's not swapping. You move X. You move Z to the front. And before you move, yeah, that would be the next step. So you move. So it's not swapping. You're moving to the front. You're moving to the front. So you move Y to the front first. Yeah, you just keep moving each next element to the front. I think it's the basic algorithm, and then you can use double pointers to kind of make things easier, I suppose. So you have this. You keep updating this pointer too. This previous node point would point to, if it exists, would point to your next value. This value that comes just before. You need a pointer to that one as well, because you need that to point to. This has to reset itself to point to the next thing when you're reversing. That's a tricky thing. And yeah, so you do need actually 2 pointers then. You need both of these two. The next element that you're going to move to the front, and whatever is behind it as well. It's previous element. I think that's what the double pointers are for. Man, the allure of atheism is strong for so many. For me, it always helps to remember that if I was an atheist, I wouldn't be alive. Really interesting. Well, I don't have the same story. I'm troubled more than ever about other people being atheists. Yeah, it's a pretty troubling thing. Let me, Melita, let me get back to that, only because I do want. This is actually like a hard LeetCode question, so it's like I probably won't be able to solve this very quickly. But I'll very quickly add a couple things there before I move on. it's very sad. Those that are perishing, we want to. They're all going to go to hell for all of eternity. It's horrible. It's really sad, and they're going to do it to themselves. They're going to deserve it. They're going to do awful things in their lives against sin against God, as we all have, and we all do. That's the first thing. Second thing, it's so important to preach the gospel, the saving grace of Jesus Christ, the saving grace of God. What Jesus Christ's sacrifice has done for us, right? The bad news and the good news. So important to preach that because there are lost sheep out there. There are people that are basically not yet Christians, but would be Christians if they heard the gospel. And so it's so important to tell them and convert them, have them converted so that they don't go to hell also. Presumably they'll go to hell whether or not you preach the gospel to them, but presumably they will be saved whether or not you preach the gospel to them. But it's still, that's the means that God uses. That's what we've been commanded to do. So it's extremely important to do that. And then the last thing to say is, there's a lot of things about atheism that there are a lot of problems. For Christians, very obvious. But like one of the things few things I've been thinking about lately is like, atheists, anybody who's not a Christian really, they would reject Christ because they love their sin, not because the gospel isn't true. And you'll notice that over time when more and more you talk to them. You'll also notice that if they're very like resiliently, they're rejecting you very harshly. Don't waste your time because they'll have questions that aren't really good faith questions. They're more like trying to trap you kind of questions, and then if you answer those questions correctly and show them that they have trapped nothing, they've only convinced themselves that they've trapped you, then they'll just go back and get more questions. They keep trying. Like it's just an endless loop. You'll never get to them basically. And then the other issue is also just something I've been thinking about a lot lately. Is like atheists, they actually don't have an answer to suicide. So life is suffering. Basically, your body's going to fall apart over time. That's what aging is you basically just start collapsing and breaking down, and it's extremely painful and it's very sad and tragic and all of that. You will die. And so for an atheist, there's no reason not to commit suicide, because if you're just going to be suffering until you die, you're going to just endless suffering. Why not just end it now, right? Like why wouldn't you just basically take the utilitarian approach and say, well, if I'm going to be hedonistic and trying to reduce suffering in my life, why not just stop, And the atheist really doesn't have an answer to that in their worldview. But the Christian does. It's self-murder. It's a sin, and God calls us to endure to the end. One of my family members was in a bad place these days. It was sad. The thing about it is that it only excludes God. Someone they've never seen or heard before could go to a stadium and the whole stadium could be atheist, but in the end, what will they focus on? Enjoying the game. Yeah. I mean, all things. What is it? God's in control of all things. So you don't need to be in too much despair. But it is a sad thing that we've all been traitors to God. It's a horrible thing. It's a horrible thing. And I say this as someone who constantly sins. So not constantly, but often enough where it's really terrible. I struggle a lot with sin. I mean, there's some weeks where I feel like no problem. Like I got this under control, some certain sins that I struggle with, and then there are other days where it's like I just get flattened, and I'm like, it's terrible. But anyway, yeah. Let me focus on the problem though. Let me just get back to that. If you don't mind. I'd love talking about God. Don't get me wrong, love talking about God, but and that's actually a case where I could confidently say love. But I do want to sort out this problem. So the tricky thing here is, you have 3 nodes, and you're going to move one of these to the front of your list. So this node now has to point to this node. Will now has to point to this next node. So there's sort of pointer A, B, and C. So B points to next of C. C is going to be moved to the C node itself is going to point to A. A is still going to continue pointing. Excuse me. There is actually one more node. There's like a sort of a previous node or head node that we need to keep track of, and that's going to point to C. So if we said A, B, C, we're going to say first things first. We need our next node D. So we have to point to D, and we need a new pointer T1 to point to C, and T2 to point to D. And we're going to say, because these are going to be sort of our next nodes. B, so T1 actually is going to point to B. I got that wrong. So it's going to be T1 points to B, T2 points to D, whatever this is pointing to. And we're going to say C is no longer going to point to D. It's going to now point to C is going to point to A. A is going to continue to point to B. B is going to point to D, or to T1. And B points to T1, C points to A. And then finally, this guy, we'll call it X. This is then going to point to Z, or to C. So A doesn't change quite exactly. A doesn't really change. B and then we have B then points to Z. A points to Z, gets updated to Z, or really it would be gets updated to C. B gets updated to I'm sorry. No. Sorry. A gets updated to C, which is now in front. B gets updated to, it really would be the node before, right? Hold on a second. B actually, so that's really tricky. How did I do this the first time? Maybe I'm wrong. Maybe I can't do it this way. All right, friends. Yeah, I appreciate it. Thank you. I think I got this wrong. I don't think it's that easy to. B would need to go backwards to the node before. How do we update this node appropriately? Can I do this with a singly linked list? Can I not do this with a... I thought you could do this with a doubly linked list. Am I crazy? Yeah, because the problem is that X has to update itself, B has to update itself to point to... Yeah, that's fine, but the problem is you don't have the previous node. You don't easily have the previous node. Oh, that's awkward. Well, what you can do is you don't, I guess what you could do is you don't actually need to update B just yet to the end. You only need to do that when you're done. So you just need, so yeah, I see. So we actually don't have to do this part until we're finished. Right, we only have to do this once. And that's actually going to be the last node that we operate on. So when you can just set this, you actually don't need to set this to anything. It actually would be pointing to Z. And when you move I see. Oh, that's interesting. So actually you don't need to modify, you don't need to do this one at all. So you don't need this at the end. This actually can be, let me think. When do you need to do this T2? It's just the first time, actually. It's really just at the end, this T2. This D, so it's not even T2, it's just D. So you just have D, and you have X, we'll say. You really only need to update X once, one time at the end, and you only need to update D, pointing to D at the end as well. Everything else in between, you can just say, you actually don't need B then at all. You could just have A and say Z is going to be placed, so C, or we'll call this B. B is going to be placed in front of A, and then, but how do we get this one, this node? How do we actually do these things? Well, you could put y. Oh yeah. No, never mind. You're not doing the back first. You're doing y in front of x. I think it's yeah. I think I have this wrong. I think we're doing it wrong. So let's do x, y, z again. All right. So first you put y in front of x, and you have a and b. So b goes in front of x, and then connects to x. So b in front of a connects to a, and you're going to update a and b to. So you'll have y, x, and z. And you want to update a to x. Excuse me, no, a stays where it is. B is updated to z, right? B is updated to z, and then you want to move z in front of a. And you would repeat this over and over, right? And this b will keep moving to the right. And when you're done, you'll have a, you'll have b, and you'll have you have this next node. We'll call it c each time. So we could pick up c here. And you're going to update b goes to c. B then is equal to c. This is sort of a temporary value c. B equals c. And then you're going to operate on c next, right? And the trick is c is that next node. So yeah, you always have b, you always have c. The tricky part is you have some c here, and you're going to set at the end, when you're done after all the iterations, you're going to set b next to, instead of it going to a, it's going to be c, right? And then you're done. Otherwise, though, you would update b to where c is, and a doesn't change. Actually, a would update to what b was, right? So a points to what b was pointing to, b points to what c was pointing to. So a becomes b, b becomes c, and you keep going. So you can sort of take one node at a time that way. And then at the end, you wouldn't set b equal to c on the last iteration. You don't update b to c. On the last iteration, you're gonna set b next to c. Yeah, on the last iteration, I'm trying to think how to do this. At the end, we're gonna update x to point to a. Or not x, but we call it alpha. Call it alpha. Alpha is gonna point to a. And then also at the end, this. Now, what's weird is this very beginning node is actually the one that ends up pointing to C. It's not B. It's actually, so yeah. So then you do want to have something pointing to this very first node that we're going to move. So you have something pointing to this very first node. That actually is going to point to C at the end. So we're going to update B to C. Actually, you're going to just end up updating at the very end. B is pointing to this guy. This actually is where B is pointing. So really, B equals C. B ends up pointing to this, and then you just have this sort of original. Call this beta value. So beta ends up unchanged, points to B at the end. So you really just you have A, B, and C. A, B, and C in a row, and you have B is going to become the front. So B next goes to A, B next equals A. A updates to what B is pointing to. B updates to what C is pointing to. And you keep going as many times as you need, right? And then at the end of that, you have a beta pointing to A initially that you don't touch, and you have an alpha as well that's actually pointing to the node just before X. And so that alpha node, if it exists, will then update. Now, the reason why you use double pointers instead of a well, actually, it doesn't matter. It's got to be a node. Yeah, never mind. That doesn't really matter. So, yes, there's a previous node that we use, and if it exists, and we're going to point that at the end. That's going to get pointed to what A is, whatever A happens to be, and at the end, beta is going to point to whatever B is pointing to, and we'll do it that way. And I think that works correctly. Yeah. So, give that a shot. That's, I think, the whole routine. Kind of complicated. Also, 30 minutes in, yeah, quite more involved than I was expecting it to be. But so this previous, we'll call that, we said alpha. So we'll say list node, alpha equals previous, doesn't change. List node A, B, null pointer, B equals the null pointer, and C is the null pointer. Say A, B, and C pointers. And we also have, we just call it beta, is going to be, alpha is previous, beta is equal to R, and A will start off at R, B is going to be R next, and C is R next. We'll say if R, then we say B equals R next. And then if B, then really it's if A. If A, then if B, then we'll say C equals B next. Say A next. So we start off A, B, and C appropriately. And then we're going to say for decrement n number of times. We're going to say, again, we're going to say B. So we'll say B next equals A, right? A updates to B, B updates to C, and we would say, and I really would do this each time, I think. So if A, B equals A next. If B, C equals C next. Just thinking. And this actually is the beginning. You don't really update B that way. You just set B initially to A next. And if B, and also, so if B, set C equal to B next, right? B next goes to A is then set to B, and B is equal to C, right? And I think we also need B next, yeah, if, and B also. So B could not exist, and then you'd have problems. So actually, really this happens every time. Oops. Yeah, B could be non-existent, and then we just don't do anything. So then you said at the end, you say alpha next is going to be equal to A, and beta beta next is then equal to C at the end here. And that ought to do what we're looking for. And now we're going to say for int I equals 0, I is less than iterations. Or you could just say iteration. You could do it this way too. I like to do it this way. Can actually do, this is an interesting way of doing it. Iterations minus minus is like the goes to operator. If you put a 0 in there, it's the goes to operator, it goes to 0. But I kind of prefer this way. So that is all you need to do. What you would say is start from the head. You have sort of list node x equals head. And we're going to say for each iteration, reverse list section of the previous is, yeah, we'll do previous, which is the null pointer, and then the head. Oh yeah, I forgot. Oops. Forgot something here. So the if alpha exists, so if alpha, then alpha next equals A. And beta dot next, technically this could be empty, this beta, this R. If A doesn't exist, then all of these don't exist. Then this doesn't exist, and so you could actually have a situation where this doesn't work out either. It doesn't need to be touched either. Technically, if you're on like an empty list, you could run into issues. Still here. Hey, welcome back. Or not welcome back, but hello. I'm grateful you're still here. I'm grateful. One problem with this is we probably do want to return a list node. We probably want to return the list node to the, it's going to be beta, actually is what we want to return at the end. Yes, so auto, or not auto, but list node tail, or my what do you call it? My washing machine has been giving me all kinds of problems because I keep bumping into it when I'm walking over there, and it's giving me issues lately. So how are we doing? 38 minutes. Okay, not great. I was kind of hoping to do this quite faster because I've seen this a few times before. So it's not the tail. It's sort of penultimate, I guess. Well, I guess it would be the tail. Yeah, it would be the tail. So that tail, we could start with previous and x, and n is iterations is k. And then what we're going to do is update previous to tail and x to tail.next. And if we say if previous, or if, so we'd say if tail, then x equals tail.next. Previous to tail. So we reverse everything, we get the tail, we want to say previous is that tail and x is that next spot, and as long as x exists and we have more iterations to perform, then we're going to reverse that section, reverse that list section, and then we get our tail, and we update our next value to tail next, and our previous value to tail, and we repeat, keep iterating. Something like this ought to do the trick. And then we return at the end of all of this. This is kind of interesting. So we want, when we reverse the first list, we need to get that head, which is the first tail, which is kind of neat. It's not the first tail. It's actually the it's actually beta ends up. Sorry, it's a little confusing. So yeah, beta is the original head that ends up all the way at the end, at the tail. The last thing. Oh yeah, so actually, the head. This previous doesn't point to the head anymore. This is a null pointer. What we can do though is we can have a double. We can have a. This is kind of interesting. So we can make this, instead of a previous node, this could be a double pointer. That's super confusing, but what it would do is, what this allows us to do is to point this double pointer. It would point to a pointer that points to the head. I'm trying to think. The reason why we'd want to do that is we'd want to actually. It's kind of awkward, but basically we want like more than one return value here. I mean, maybe we could just use a tuple and return a pointer to the. Yeah, I don't know. Maybe I'm thinking about this incorrectly. So I think what I want is beta as the tail, but I think I also want something that points to the new head. So after everything's been reversed, there's sort of a new head. There's a head and a tail, I guess. I mean, we could do it that way. That's fine. Yeah, okay. So we'll do a tuple. That's fine. I think it's okay. I think it's okay to use tuples. Return two return values. I'm only going to use it once, but I think it's okay. So tuple's fine. We can do. We want alpha is more or less the tail. No, excuse me. Yeah, alpha. What alpha is pointing to really would be A. Is A, and then beta is the tail. We want the head and the tail, so. And so let's say head and tail. So A is the head, and beta is the tail. Yeah, that's fine. So head and tail. So now we can say just auto t for tuple. We could use something like the following, like const auto pointer head tail. I think that works. And then we're just going to say, or ht rather. I think what we want to do is say list node new head equals the null pointer, and we're just going to say over here if not new head, then new head equals t equals h, and then at the end of this return the new head. Something like this. Let's see if this compiles. They're good problems. These are good problems that you're solving. Thanks. Thank you. Thanks. Also, this should be int. Thank you. We're doing on time. All right, 45 minutes. Let's see. Oh, it's a pointer. Oh, maybe that's why we were using double pointers before. B is, so if A, B is going to, it's actually going to be the address of A.next. And then B.next, oh yeah, so B is a pointer, right? So B next, oops, not B.next. And A next as well. I think that's a little confusing, but yeah, we're using the addresses here. C is then pointing to the address of B. B next is then pointing to the address of A. And then A updates to B, B updates to C. Yeah, it's that's definitely a bit confusing. Alpha next, these are all pointers. Beta next, and these are as address of A, address of C. Hopefully I did that. Yeah, I can see why it's a bit confusing. Let me see. A pointer exists, then you can take the reference of A next. Oh, now also interesting is that this could not exist as well. This is a null pointer taking the address of a null pointer. I don't know, can you take the address of a null pointer? Oops. What does that do? Does that compile? Yeah, that's why I use the double pointers. Oh. How about this? Test 2. I don't know, it's just something. Test and test 2. Let's see what happens when we do this. Cannot initialize. Well, actually, no, it's not. Oh, I see. So we don't take the address. So I think I'm doing that wrong. Well, whoops. You could do list node equals. Oh, I see. So if you did. Oh, that's super interesting. So A next can be a null pointer, right? And we would take the address of that null pointer. But if you take if test is a null pointer and you try to take the what is that's so confusing. So A next is a pointer, right? Not, yeah, you wouldn't take an address of it actually. Excuse me. That's really confusing. So yeah, okay. All right. You're not taking addresses of things, but you are going to take an address of A, right? So A is a pointer also. These are all pointers. Why am I running into issues here? That is so confusing. I don't know. We'll see. That is very confusing. No matching function, make tuple. You actually don't need this. But that shouldn't. I thought that'd be okay, but alright. Oh, okay, we are gonna update. That's not const. That is not const. Declare with const auto. Declare type must be auto, reference to auto. Really? That's interesting. Reference. Oh, yeah. Wrong answer. Okay. Output 32154. Expected 21435. All right, so it's pretty close. The K should be n minus minus. I guess it is minus minus n then, right? So if K is 2, Oh, I see. Okay, yeah, we do a minus n. That's fine. Okay, that's better. But oh, I see. Yeah, because it did it. Yeah, okay. Oh, it worked. Oh, no kidding. Huh? How did we do? How did we do on time? 50 minutes. All right. Ooh, that would have been okay if 50 minutes if I hadn't gotten it wrong. Wouldn't be great though. I should have been able to do this a lot faster. I think like 3 or 4 minutes. So the second to last one is the test case that fails. We're gonna try to find out why. Give me just a moment. Interesting. Oh no, I'm gonna leave that. I'm just thinking, is anything incriminating here? No, we're fine. So that's interesting. This test case fails. Why? What am I missing here? What am I missing here? So I think the issue is B, this beta at the end. We said beta next goes to C. So C goes to B next, C equals B next is then updates to A equals B equals C. Alpha, if it exists, alpha next is set to A. So for some reason, yeah, if you just do one iteration, so this never happens, right? Oh, I see. Okay. I think you need to do all these things. Yeah, at least once, right? So, yeah, okay. Yeah, I think that's probably the issue. I see the problem. So if B, then C is B next, and then what do we say? B next equals A. I don't think we need this part. Let's see. I think this might be the problem. So this happens even if you're at 1. So 1 through 5. A, B, C. Why is this incorrect though? Am I crazy here? A equals B and then C. C is in B next. A is A next. A, B, C. If it's just one element, then what do? You would. So if it's just one element, the problem is that if I think we should do it this way. Yeah. B has to exist, right? So the thing is, well, okay, that's kind of awkward. So if n is 1, then this doesn't enter this loop. We have A, we have B, we have alpha, beta, previous is alpha, A wouldn't change, it's still the head of the list, right? If alpha exists, beta is equal to itself, beta next to C. Oh, I see. Well, yeah, I guess you do want if B, but B, no, you really want, kind of just want this to be null pointer, and then you'd start off with A exists, and then you say if B, let's set both of these to A next. Let's do it that way. So, yeah, both of these are set. B and C are set to the next value, and then that way you can set beta to point to the next value, and that shouldn't destroy this, I think. Okay, yeah, I think that's good. I think we'll do it that way. It's kind of tricky though. This is like kind of messy. But the problem now is this doesn't work for the other cases, right? This actually, we do one too many. Oh no, it does work. Oh, okay. All right, that's fine. Yeah, it's kind of handling degenerate cases. This is kind of involved, man. This took a while to kind of explain it, go through it all. Almost an hour we're at here. And are we correct? I'm not entirely sure. This took quite a bit of finagling. Let's see what we can do at the end. Are there any other cases we can try? So we could try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's try 16. And let's just do 1, 1, 2, 5, whoops, 10, 20. Oh, actually, you said it's got to be, okay, it's got to be almost 16. 16, and then, I don't know, 4. Let's try all those, see what happens. Hopefully we get this. I don't know, man. I think, yeah, all right, let's go for it. I don't know what's going to happen. I think we're okay. I think we got it. Let's find out. Hey, you got there. Sweet. Nice. That's very efficient. Not the best memory usage, but super efficient. So there we go. Not bad. We'll update the name to solved. I think I'll end it there just so we're under an hour, and then I'll actually start my live stream again. Stream could not be created. Uh-oh. Oh no. What happened? Did my live stream die? Oh no. Oh no. Uh-oh. I'm actually gonna restart the stream, I guess, just to chat with anyone that wants to chat. Well, actually, I might not do that. Well, oh man. I think we're okay. I think we're okay. I'm just gonna edit the name of this before I end it. So what I'm gonna do is solved. Let me edit the name, end it there. There's probably a better way to do this. Let me end it here just so it's in one video, and then I think I'll just stream again, just like chatting for a moment. Let's do that. All right. Thank you for watching. I'm gonna restart the stream in a moment.